Now in rectangle, angle between the adjacent sides is 90 degrees, first one. And as you know, AB equal to CD and AD equal to BC. That should happen. Is that fine? So you can say like this: in a parallelogram in which all four angles are at vertices or right angles, that means 90 degrees, is called a rectangle. But it should be a parallelogram. You keep it in mind. Or else you can say that angle between the adjacent sides is 90 degrees and opposite sides are equal. That you can say. Okay, is that okay, guys? Fine, that's nice. That's nice. And so what do you do now here? Same, almost all properties are same except this, but they will be little more things. Yeah, that's what. Okay, this one. Okay, now same. What I'm saying, this equal to this. Okay, this equal to this. Okay, and this is the midpoint. Okay, this is the midpoint of this diagonal. Okay, and this is the midpoint of this diagonal too, because they will bisect each other. Okay, fine. Now opposite sides are parallel and equal. Opposite angles are 90 degrees. This and this is how much? 90 degrees opposite angles. You keep that in mind. And then diagonals lengths are equal. Diagonals are equal and bisect each other, not necessarily at 90 degrees. This is need not be. Will you say this is 90? Important observation. Star I'll keep for it. Will you say this is 90? Who is this? 35. Yep. Nice. Okay, right. Nisha, fine. This is need not be 90 degrees. Need not be 90 degrees. Need not be 90 degrees. Okay, fine. That's okay, great. And then, yeah, what's up? You can say that perimeter of a rectangle. So, if you wanted to maximum area of this rectangle should be a square. This rectangle should be a square. In that case, you can have maximum area. So, in one more thing, in circle there is a rectangle. Okay, this is what? Rectangle. You can think this is a rectangle. Okay, so you know that this is 90 degrees now. When you join this diagonal, this is passing through the center. Always center passing through the, see, diagonal passing through the center for rectangle. Okay, this what? This diagonal also passing through the center, because angle in a semicircle is 90 degrees. This is 90 degrees already we know. So angle in a semicircle is 90 degrees. That's why this is a diameter and this is also a diameter. Okay, right. And see, in a rectangle, intersection of all angle bisectors. You know angle bisectors? Angle bisector. This is the one angle bisector and this is the one angle bisector. Fine. Now, quadrilateral formed by joining the midpoints of intersection of angular bisectors of a parallelogram is a rectangle. In a parallelogram, what you are doing? In a parallelogram, this is a one angular bisector you take. This is another angular bisector you take. Okay, and then yeah, it forms. Yeah, you wait for it. Every rectangle is a parallelogram. Will you say this rectangle is a parallelogram or not, guys?
Yes.
Because this has extra property that this has extra, yeah, this has extra property, diagonals are equal. Okay, rest of the things are all same. Okay, every rectangle is a parallelogram. Will you say parallelogram is a rectangle?
No, sir.